Hello, everyone. Welcome to the sixth RISE webinar series. I'm really excited for you to join us today. For those of you who are joining us for the first time, RISE is a social enterprise NGO that's situated in Lesotho, a landlocked country in South Africa. We recruit graduates in built industry and take them through a hands-on learning experience, while at the same time, we solve infrastructure problems in rural communities. Today, we're joined by POA Projects and PR5 Studio, and we're going to talk about earth in construction, or compressed earth technique, which is one of the oldest known construction methods. So please remember that you can leave your questions in the comment box if you're watching from Zoom, and on Facebook comment section if you're watching us live on our Facebook page. Also, kindly remember to mute yourself when you're not talking. First, kindly let me introduce my guests. We have Valentina Riveso. Valentina studied architecture at Politecnico di Milano and Universidade Autónoma de Lisboa after graduating in June 2020 from a post-degree master in sustainable and emergency architecture in Barcelona. She started working with us at RISE and finally joined our team in Maseru 3 months ago. We also have Veronica Soncini. Veronica is an architect with more than 5 years experience. She has studied at Politecnico di Milano and at McGill University in Montreal, in California. She has been working for 4 years for the awarded London-based practice in Tate Hilde, and 2 years for the awarded Milan-based practice in PR. At the moment, she is starting self-employed career, shuffling between Italy and the UK. She also collaborates with 2 collectives of architects with a main focus on social architecture. The third guest that we have today, last but not least, is Alicia Machiavello. Alicia is a PhD candidate of Politecnico di Milano about the housing issue in the Global South. She graduated from Politecnico di Milano with a thesis developed in collaboration with the Royal Melbourne Institute of Technology on the theme of participatory design, experimenting directly within Aboriginal communities. She attended post-degree masters in IUAV of Venice about emergency and resilience architecture. She's also part of PR5 Studio, and she works on collective architecture with a focus on social, economic, and environmental sustainability. Welcome, ladies.
Thank you, Daddy.
Thank you.
Thank you. Now, the ladies are going to present on earth in construction, just a very detailed presentation. And then remember that you can leave your questions in the comment box right here on Zoom if you're watching us live, or on Facebook in the comment section. Thank you very much. Ladies, please, the floor is yours.
Thank you, Teddy. Hi, everyone. I am Veronica, and today with Alessia and Valentina, we are introducing the work that we carried out as POA and PR5 Studio. So the first thing we want to do is to thank RISE for the opportunities that they gave us to let the world see our work and bring the focus on the earth in construction topic. So Vale, if you can, yeah. Okay, so as briefly said, we are part of POA. That is a group of 8 women, all architects, who share the same enthusiasm for social design and architecture. Also part of the POA team is also part of the Milan-based studio PR5 Studio that is responsible for the case study that we will present it today, that is the school in Majimoto. As a group vision, we think that the participation with the community is the key in sustainable design development. And we also think that the project can enhance the local knowledge where the technical resources become a focus point. So the earth in architecture is very important for us in our research. Today's presentation will start with a brief introduction on the built environment evolution and how that has led to a climate change, and then passing on to a more focusing point on the earth in construction and how this material can be used with different techniques. In particular, we will focus on the CSEB. There are the compressed stabilized earth bricks that were the main resource that we use for our case study, the new classroom for the elementary school in Majimoto. Starting with a brief focus on the built environment evolution in the sub-Saharan context. In the past and still in some areas of the country, the main resources used were the traditional construction materials, such as wood, mud, and stones, that of course there are natural resources easily to be found in the local context. Although in the latest year, due to what we can say a run towards the modernization, the use of the earth is actually reduced a lot. And it moved towards the use of the fire bricks and concrete blocks as the main construction materials. So the fire bricks in particular results pretty bad for the environment if we think about the amount of wood that is actually needed to cook the fire. As per the cement blocks, there is this idea that the cement is the toughest material, the most resilient, the everlasting, and doesn't need lots of maintenance. All concepts that are actually related to this urban modernity opposed to the rural context. In reality, behind this idea of modernity for the concrete bricks, hides like a massive business that has led multinational and local companies to produce and establish their industries all over the country. And as you can imagine, the cement produce a massive impact in terms of emission sources. Moving to the next slide, yeah. As you can understand, the main consequences for the environment is for sure the deforestation of lands to get the prime source of wood that needed to be invested in the production of both fire bricks and cement blocks. And the deforestation as its main consequences sees many episodes of flooding, and also the typical rainy season in those areas has been affected by this phenomenon. At the same time, those massive industries all around the countries produce, of course, has increased the greenhouse gas and also continue to cause topsoil damage. So yeah, now I leave the word to Valentina that will be introducing the part on the different techniques that uses earth as the main material.
Thank you, Veronica. So yes, before actually talking about the different earth construction techniques, what we like to highlight is like a few things to take into account when talking about. I can hear sound. Can you hear me?
Yes, Vale, you had some problem connection, but now I think it's okay.
Okay, I think I'm good now. So yes, sorry. So before talking about the actually earth construction techniques, we would like to highlight a few things about to take into account when talking about earth in construction. And in particular, we want to highlight the great potential that construction with earth has in the quest for sustainability in the built environment. Another important thing to highlight about sustainability and about sustainability of a construction material is that we need to take into account the environmental, the social, cultural, and the economic impact. So regarding the environmental impact, as a natural resource, earth has a relatively low impact since it's locally available, readily abundant, and also easily extracted. In addition, it is good for climatic control and also moisture control. In fact, earth like evens out temperature fluctuation and also to stabilize the humidity impact. We can say that earth construction sustained building tradition, as in many countries and culture, as Veronica was saying, earth has been used in vernacular architecture. Although earth construction is a common building material, there is a kind of social stigma around it, and also a perception of something as like poor and rural. So there is the need for the creation, for the production of prototypes, as our project could be, to demonstrate the potential of material. And also removing this kind of social stigma can help us to equalize community. Finally, about the economic impact, promoting earth materials where there is this tradition, can help to develop skills and expertise that may be advantageous for securing work in the future, but also in the immediate context that can provide jobs. Earthworms, they may also help us to cut down energy consumption and energy requirements. And finally, if well constructed, earthworms, earth buildings are durable and also have a relatively long lifespan. So now passing in the other slide, sorry. Here, we would like to show you briefly different earth construction technologies, and then we'll present a little more details of the one that we actually have used in our project. So in the first column, you can see projects built with, yes.
Now we can see the slide, but
can you hear me?
Yes.
Okay. So if you can see this slide, I would like to present briefly different kind of earth construction techniques, and then go more in the detail of the one that we have used. So the first one is Rammehearth, is a structural wall system that is made from damp sand, gravel, and clay. You need to use a formwork, as you can see in the first picture. And you need to pack it and dry it. You can proceed with the next layer until the wall is completed. The second technique is earth bags, or also known as super adobe. And the technique consists basically in introducing soil and a smaller band of a binder in the bags, and then create layer. The bags are stacked one over the other one, and then compressed to regularize the contact surface. And you can also add barbed wire to be more adherence or the layer between one and the others. The third technique is adobe, or also known as mud bricks, and is a mixture of sand, clay, water, and sometimes usually we have also, and the mixture needs to be smooth without gravel and rocks, and then you will create bricks with the kind of mold that you can see in the picture. The last technology is the cope, is another kind of mix, and this technology take is a long process and a very long labor intensive. Is mixed of sand, soil, straw, and water also in this technique. Lastly, I want to go a bit more in detail of the technique that we have used in our project. That is the CSB, that stands for compressed stabilized earth blocks. So this technology is the one that is more suitable and is being actually implemented around Africa in the urbanization process, and is mostly because compared to some of the technologies that I present, taller and thinner walls, and also has a better compressive strength. So these technologies use different typologies of manual or motor-driven machine to compress and create the blocks. The mix for these blocks is composed of damp soil, sand, and a chemical binder as a stabilizer that can be cement or lime, and the average is between 3 to 10%. So it's important to notice that it's important to like identify the property of the soil to create and perform a good products for then create your blocks. So for like cement stabilization is usually better for a more sandy soil, for the more clayey soil. So once you have your mix, you pour into the machine, as you can see in the picture. You compress, and then the bricks are water cured for around 5 weeks. So in our project, we assess that a skill team of 3 members can produce around 400 blocks in 8 hours work with one machine. And also that with 1 bag of cement, you can produce around 150 blocks. So finally, about the shape of the blocks, there are different typologies of compressed stabilizer blocks, and we use 2 different. In a project that we have done before the classroom, we used the normal one, but then we realized that using the interlocking one, that are the one that you can see in the drawing and also in a picture, you can increase the structural stability, and second, you can reduce a lot the use of the amount of cement needed for the mortar. So yeah, those are the characteristics of these technologies. And now I will leave the floor to Alessia, that will talk about our project, the classroom for Magimoto. So to you, Ali.
Good morning to everyone. Let's wait for the next slide. Okay. Welcome to the Magimoto Primary School. We built the classroom you can see in this picture in 2019 in Magimoto. Magimoto is a rural village in the northern Tanzania. As you can see, once finished, you would not able to recognize at first sight what material is made of. But I give you a spoiler. This classroom is made in CSEB blocks. So now I show you how we use it in a real context, and also how we introduce this new construction material in the Magimoto community. Next slide, Vale, please. As I mentioned before, we are in Magimoto, Masai village in the northern Tanzania, 40 kilometers from Arusha, at the foot of Kilimanjaro mountain. Let's wait for the slide. Okay. For lack of public transport, Magimoto is isolated, which means its citizens are not able to receive sufficient health care and education. It also be taken into consideration that the population of Magimoto has more children than others. Next slide, please. Waiting for the next slide. But anyway, this the things is reflected in the school where there is an overcrowding of children in classrooms. And this is for this reason that PR5 has developed a master plan, the ones we will see in a while. Okay, this one, a master plan for the school complex, which includes, in addition to the renovating of the existing building, most classrooms are in terrible condition, as you can see in the picture, and are not sufficient to accommodate the growing numbers of children. The construction of 6 new classrooms, a new toilet block, a new home for teachers, a canteen for children, but also with the dual function of a meeting place open to the population of Majimoto. And finally, we planned also a storeroom for the existing kitchen in order to give the possibility to cook and have a service, internal service of kitchen for the classrooms. But now let's focus on the first classrooms, the ones you have just seen in the first picture, and of which I will now show you the details of the construction phase and techniques. The classroom was the first intervention carried out by us. After a design phase is carried out remotely between Italy and Tanzania, where the PR5 team often exchange views with the local community, technician, with the help of a local NGO, where we arrive at the definition of the project. From Italy, we raised the necessary funds for the construction of the classroom. And once we arrived in Tanzania, we had already defined all the details and we were ready to start the construction site. The construction site lasted 5 weeks, one of which was used for digging the foundation. And the classroom was built by a team of local specialized workers helped by volunteers. In terms of technical details of the construction, the elements of the classroom and the material used are: for the foundation, we use reinforced concrete cast in situ. Now we will see a series of pictures of the construction site so you can understand better what I'm speaking of. Then for the load-bearing structure, the load-bearing structure was made of reinforced concrete pillars and edge beams. Let's wait that the picture are coming. So, okay, this is the foundation part. Then we have the walls, and infills are made of earth bricks, the ones that Valentina was showing you before. Then the walls were plastered. The doors and windows are made of iron frame with bamboo interlacing, and the roof is made of corrugated sheet metal fixed to iron trusses with lateral iron frame filled with woven bamboo. The roof system, together with the false ceiling made of woven bamboo panels, was designed in order to create a ventilated roof to prevent the overheating of the sheet metal and therefore high temperature inside the classroom. This is therefore important to say that the compressed air bricks were used as curtain walling and not as a load-bearing structure. Also, the brick we made have been tested for their strength, and the results have been submitted to the civil engineer in Arusha. They are not, but anyway, they're not recognized as usable element for load-bearing structure, which has therefore been built with the old reinforced concrete beam pillar system. We also have to remember that in this case, we are talking about public buildings, so we have a regulation that is quite strict. However, the theme of the both economical and environmental sustainability was the basis of the research within the limits of regulation. In addition to using sustainable, inexpensive, and easily available material, our aim was to reduce the waste of building materials to zero. For example, the wood of the windows, the colored pillars on the facade, and the benches came from recycled wood previously used for the framework of the foundation. I think it's also important to tell you about a less technical aspect that is not visible in the reportage we did, I mean through the picture, but is the more human aspect of this experience. When we decide to propose the use of compressed air brick for the construction of public building to accommodate the children, we were aware of the challenge we were facing and that we had to work hard on absence of involved population by demonstrating them the potential of this material. It is true that we were collaborating with an NGO active in the area, which did an excellent job of intermediation, and that there was a construction site for the local dispensary built using the same technique. But it would not be active, the dispensary would not be active before the new classroom. So the classroom was the first building made of earth brick that could actually be used by the community. It was therefore important for us to try to involve as many people as possible in the implementation phase, starting with employing as many local skilled workers as possible who could experiment with these techniques, implementing their knowledge, and in order to be able to reproduce it on their own in future. We try to make the construction site open, involving men, women, children, that saw the classroom grow step by step, seeing all the construction phases. Everyone knows what lies behind the last layer of plaster. It's not a secret for them, of course. Now they also know that there are alternatives to cement bricks or red bricks if they wish. And then the result is just as beautiful and comfortable as the previous one, if not more. The strategy of constructing public building with an innovative technique, it makes these techniques available to everyone, so that projects are lifted and performance can be monitored all the time. As I told you before, the construction site was completed in 5 weeks, but the story doesn't end there. Vale, can we go to the next one? Thank you. We purposely left the classroom complete, but with spaces for customization, especially inside. In fact, as soon as we were back in Italy, we were informed that the classroom had been painted yellow and blue inside, like the first picture you can see. And the children hang their drawings, the desks, and have been placing everything was ready to welcome the first children. Classroom continued at full capacity for a few months, but then there is the story that we all know, sadly, that COVID arrived also in Tanzania and also, close to Majimoto. The school closed for a few months, and in order to reopen safely, they had to face the main problem: how to ensure basic hygiene for children. They built a cistern to collect water and hand washing station on the sloping roof of the classroom. The picture you can see here. The new classroom is now, even more than before, the centerpiece of the school complex. It was only a few days ago, however, that the side wall of our classroom was painted by Colgate to promote good oral hygiene practice. It is a source of pride for us to see how the school staff take care about this building, how they take care of it, and how they promote the initiative, and how it has created a sense of belonging. We documented the construction site by filming all phases of construction. The reportage became a documentary which was presented at the Design Film Festival in Milano. We will now show you the trailer of the documentary and I'm gonna leave you the link in the chat in case you want to see the full version. If you're interested in the story of the class and if you want to better understand the step of its construction, I invite you to watch the documentary, which is certainly more exhaustive than any story told through words. So let's see the trailer, and in the meanwhile, I'm put the link in the chat. Va.
Una strada lunga e dissestata, però
I think there is a bit of internet problem, Vale.
Can you hear me? You were not.
Yes, but the video is stopping all the time. So
Okay. Ale, maybe you can share it?
Yes, I try to do it now.
Sorry.
Just give me a minute.
All right, everyone, while we're still waiting for Vale to bring the video up, because I cannot wait to watch that documentary, please feel free to post any questions that you might have or any comments that you might have on the presentation that you've seen so far today. You can post those in the comment box as well as on Facebook.
Ale, non sentiamo il video, cioè l'audio, scusa. We cannot hear the audio.
Okay. Now?
Still we can't.
You can?
Well, I think it's just very low, maybe. Okay, yeah, can you start from the beginning, maybe? So I think everyone had some problem hearing what was the video about, but I think, as Alessia was saying, we were going to send the link to actually see the full presentation, the full video, if you're interested. I think it gave you the idea of the document that was made after the experience.
Exactly. I'm just put the link and the password in the chat, so you can see maybe better, and the long version of the video if you're interested in it.
All right, thank you so much. Thank you. That was a beautiful documentary right there. And I think I fell in love with the fact that you involve the community and you make sure that you leave the skills in using compressed building bricks, compressed stabilized bricks, so that they can continue building their own projects even after the project has been done. We have a couple of questions. In the comment box from Kintu. Kintu Kisule, thank you very much for joining us for this webinar today. Kintu would like to know, ladies, how do the CSEBs perform during the rainy season? Do they lose strength due to the moisture?
Vara, you want to go?
Yes, I can. Yeah, I can say something, and then if you want to add. So as you can see, like to protect the bricks from rain, you need first of all you can work with the overhanging of the roof, but it's better to like plaster it. So you will avoid the bricks to like be in the direct, let's say, exposure to the rain. Otherwise, if you want to keep the facade as it is, so seeing the texture of the bricks, you can also like, there are some materials, some varnish that you can use like are transparent and they are waterproof. But yeah, normally earth construction needs to be protected from rain, from water.
Okay. Valerie just said that they will need. Did you just say that they will need protection from water?
Yeah.
Okay, could you kindly let us know what would be used in order to weatherproof it?
Ale, can you add some details about it?
I couldn't hear what the last question that Teddy did.
Yes, the kind of material that you need to use in order to make sure that the bricks are weatherproof or are waterproof.
Okay. So by the engineer, you mean, right? Or by the community, I mean, in terms of?
Yes, by the community.
Okay, by the community. I mean, as I was tell you before, we were working on public construction. So that means there was the possibility to use these bricks and show the result to everyone. It was not a private building that is just for certain people. So that was the opportunity for us to really test it with the community and try to introduce step by step, slowly, this material. It was also fundamental to have the approved by the civil engineer in Arusha. So we provided to the community the result of what the civil engineer told us, and that was already our first step to to be sure that that kind of techniques was fine. And then, as I told you before, I mean, try to involve as much people as we can in the construction phase and show everything with no secrets, let's say, was probably the right way to approach with the community. Then, of course, time makes the rest. I mean, leave the school there and show them that also after, for example, rainy season, that you know better than me how heavy it is in Africa, and the school is still there. Well, I mean, there's any sign of bad condition and everything is fine, was definitely the step that was necessary to give to delight all the doubts of the community. And we are still in contact with them, even if it's 1.5 years that we can't go there because of the COVID. But we are still in contact with them, and they are all happy. And it's also demonstrated with of how they are still investing in the classroom with other maintenance and small project. So I think it's something that, and also was clear how they accept this new techniques. For example, the last day we stayed there, in the inauguration of the classroom, all the community participated, and the community was really proud of that, and they invite the villages around to come to see what we built there. So also to try to show other community what we can do with this kind of material. So that was for us definitely the first sign of that this kind of material was working well with them.
Can I just add a bit, going back to what Vale was saying before, is that another thing that we considered in the design about the waterproofing is that the full project is actually raised by a step, and it's not, the bricks are not touching the ground basically. So this of course will prevent the water to come in as well from the bottom, let's say. So I think that completes a bit what Valentina was saying before.
Thank you very much, Veronica. Thank you, Alicia, for clarifying that. Because I was a bit curious as well. Let me introduce my co-host, ladies and gentlemen, Queen Motlhokaqala, our construction manager, who's as curious as I am because today's topic is super interesting. Queen?
Thank you, Teddy, and hi, everyone, and all the listeners out there. I think the presentation was quite good. I've had the chance to take a snippet also on the video. I think it's quite interesting. I think from our side also, like from my side also, which is something that's very important, is does the construction need a professional to do, or is it something that anyone can do it, like people from the different communities, as long as you just show them the direction?
Who wants to go? Vale, you want to go?
No, let's start, then I add something.
Okay. I mean, what we have done there was to try to train people to how to make bricks. It's not really needed to have skilled people do that, but it's important, for example, first of all, to have the machine and then test the soil. That's the base skills we need. So have someone that is able to test the soil and find the right mix, so the good strength of for the bricks, and then have the machine. And I mean, yes, know how to use it. It's quite simple, but you must be very I mean, it's need a strong man to to compress well the bricks, because that is important, to compress very well the bricks in just one shot. And then in order, I mean, after that, after the realization of the bricks is quite easy to build with compressed air blocks, especially if those are interlocking one, because it's like to play with Lego. It's like you don't need so much mortar. Exactly, you have just to put in. I mean, we used to do that, and we are definitely not skilled workers, so that was quite easy. The most important part of this process is the one that is at the beginning. So try to find the right mix, and yeah, it should be better to have someone that are able to use the machine, I mean, yeah, and have the machine. So
thank you very much, Alisa. There's also a question from the audience from Mokotedi. They would love to know if the modules are actually adjustable, like to make different sizes of bricks. Is that possible?
Yes, of course. Like you can create different kind of molds and create so different shape. So the interlock that we use is, let's say, the most common and the simple one, but there are a lot of different kind of interlocking shape. So you need to change, or you also can try to produce by yourself the mold. It's just a matter of understand which shape you want, and with the steel produce your mold, and then interchange it, the mold in the compressed machine.
Okay, thank you very much, Vali. Jout also wants to know when he was listening through the presentation, he had that it was earth mixed with cement when doing this project. So I think his question is, was it because there were no stones to be used around, or like why used and not stones?
I mean, the connection is really bad, but if I understood right, the question was the one in the chat. So use of earth mixed with cement, was it because there was not stones, right? Isn't it? Okay. Okay, because the connection was a bit bad, so it's not clear. No, I mean, yes, actually, we haven't stones in the on site. The stones you saw in the video, for example, was for the concrete. I mean, for the concrete, but for the blocks, stones are not fine because the mix should be very, how you say,
fine,
smooth.
Yeah, smooth. So it must be. Otherwise, when you go to compress the bricks, should happen that you have, for example, some holes, or I mean, the bricks must be really compact. Okay, so stones are not maybe the best way to create the mix, and then you need something that is that take very strong the material altogether.
Yeah, exactly.
Thank you very much.
The reaction of the cement as well was to make the concrete tougher, and that's why it's called stabilized, actually.
Yeah, exactly.
Okay, thank you. One other question that we also want to know about is how long does it last, or how long does it take for this type of construction as compared to other commonly used constructions, like using normal bricks or concrete blocks, or even using timber? How durable is it?
So yeah, of course we are not like researchers in this kind of field, but for the research that we have done and for the results that we have seen in the previous almost 3-4 years with the first building that we did, we can say that it's very durable and there are no sign of aging basically in the building. because as we were saying before, the waterproofing was the most important part. So the fact that we raise it from the floor and the fact that we use either varnish or the mortar to close everything basically showed the durability of this material that is used as Alessia was saying, as a curtain wall. So for our experience is that compared to the normal bricks, those ones are better, because the normal bricks that we saw that they were produced in the village where we were, they were not compact. So they had lots of holes in it. So lots of insects going in, lots of water coming in. So that's the answer that we can give from our side. I don't know if you want to add something else.
No, I think that answers the questions.
Okay.
We have one other questions also from the audience. The question is, are there certain properties of soil one should look out for? By this, I mean, does the soil have to be sand, gravel, or clay? What types of soil is it?
So yeah, I can say something about it. So yeah, as I was saying, it's important to understand and identify the properties of the soil on site to decide if you can use that soil for producing CSP. And there are, like, obviously, if you have labs that can help you with that, is better. But there are also like kind of simple and analysis or test that you can do on site by yourself. The real first test that you can do, it's called sedimentation test, and it's just basically having a bottle filled with a quarter of your soil, and then fill and the 3/4 missing with water. You will shake the bottle, and you will wait half an hour that the sedimentation of the particles of your soil. So basically, the gravel, that is the bigger particles, will be on the bottom, and then will be sealed clay, sealed sand, and on the top the clay. And from that sedimentation, you can, let's say, understand the percentage of each particles in your soil. So at that point, what I was saying before is that if you are a more sandy soil, you will prefer to use cement as stabilizer. So what we have done. Otherwise, if your soil is more clayey, so with more clay than sand, you will prefer to use lime as stabilizer. So this is the real first test that you can do with your soil to understand the particles and the proportion on it. And then there are other tests that also can help you to understand if the actual mix that you have done is like the correct mix. So is the strength and the durability is correct. So yeah, there are a lot of tests that you can do before to produce good and well products.
Okay, thank you. From the test that you guys did, or from when the construction was being made, do you guys think it's possible to build a multi-story building from the compressed blocks?
So, as we were saying, in our project, but also in the other project built with compressed stabilizer blocks, it's important to notice that the structure is made by concrete. So it's concrete foundation and a structural with cement, with concrete. So not then our blocks are used as filling the walls, are not structural. So yes, you can build a multi-story building as soon as you have the structural that can be also like made by steel or wood. But the important is that you have a structure that supports your building. I don't know if Ale, you want to add something more technical or what?
No, it's exactly like that. For example, I mean, I designed for another work double-story building in Mozambique, and the proposal was done with earth bricks, but exactly as Vale was saying, I mean, the structure must be in concrete or anyway, or wood or anyway, something that is structure, and then you can fill it with the bricks. Exactly how you do with other type of bricks. You cannot use red bricks for structural parts, so exactly in the same way.
Okay, thank you very much. There's another question also again from the audience, from Datenja again. He would love to know, like, working with mud has effects on health, especially in cold areas such as Southern Africa. So he would love to know what kind of weather they have in Tanzania, and what are the impacts to using this type of construction materials.
So in the village where we were, the weather was actually not really cold, and I don't think it goes under zero, never, right? Yeah, I think it stays quite stable, and it changed just slightly during the rainy season, but it's all the year around, I would say 25, 30 degrees or more. So we don't really have example on cold areas. So I'm not sure if we can reply to this question.
Okay, thank you very much. Yes, I think it's also a very question whereby we need to have a thorough study on that and the behavior. Another question from Lehlohonolo Tsepi is asking if there was anything that was done to the bamboo just to waterproof it, and if there was anything that was done, what is it that was done to it to extend its durability?
Yes, of course, bamboo should be waterproof before, but the really important thing for us also was to use it when it was still soft, and because, you know, we kind of wave it in the, or just bamboo with bamboo, or on a metal frame. So the important thing was to use it straight away after we cut it, in order to have the manuality to work on it. And then, of course, we also kind of protect it with a special vernice to protect it from insect, basically. Because in the village where we were, there was one kind of insect that should sometimes infect wood and bamboo, so we just protect it to be sure that that was fine.
Thank you very much. That's quite interesting. Another question from the audience, from Kintu Kisuli. Have you used lime before as a stabilizing agent? And if so, is it economical?
So we didn't directly use the lime because, as Vale was saying, our soil was the type of soil that was needed cement as a stabilizer. So we didn't have the example with the lime. Although I believe that the amount of lime that you will need to use probably it's a very small amount as per the cement that we used in our bricks. So probably, if the question of, I'm just assuming, if the lime, that you need a lot of lime, so it's not economical, but I don't think that's the case.
No, like in the average of stabilizer that you use in this mixture, as lime or cement, is between 3 to 10%. So it depends obviously from the composition of your soil, but the maximum of lime or cement is 10% in the whole mix. So yeah. So yeah, we are not like we used cement, so we are not we don't know about lime, but yeah, this is the research that is about around it. So it's not needed to use a lot.
Thank you very much. I'd love to hand over to Teddy as we are getting to the end. Thank you very much, Teddy.
Thank you, Queen.
Thank you.
Thank you very much, Queen. Thank you. Wow. Time sure flies when you're having fun. Goodness, what an insightful discussion we just had today as Valentina, Veronica, and Alicia from POA Projects and PR5 Studio took us through the types of materials and techniques used in earth in construction and how it's one of the most sustainable methods of construction, as it has a low impact on the environment. And also that, you're not supposed to stay in the rural areas to build, the earth homes that, that are really not to have a very long lifespan. So, as Valentina was talking about the stereotypes earlier. So you can be anywhere. You can build in the city, and you can also build a multiple-story house. To be honest, I thought you took any kind of soil from anywhere to build an earth home, but I'm happy to know that you have to be selective about the type of soil you use. And you can also use little amount of cement to stabilize the block and save costs at the same time. Please see the link of the documentary, the school that the POA Projects was building in Tanzania in the chat box and in the comment section on Facebook. We would also highly appreciate it if you would let us know what topics you'd like us to talk about in the future by filling in a survey we have left in the chat box and on the comment section on Facebook. Join us again for our next webinar on Thursday, the 29th of July, next month. I would really like to thank my co-host Queen. I'd like to thank our panelists for today, Vale, Veronica, and Alicia from POA Project and PR5 Studio for schooling us today on earth in construction. Thank you very much.
Thank you.
Thank you, Teddy.
Thank you.
Thank you, everyone.
Thank you.
Fantastic
for
day.
attending.
Bye-bye.
Bye.
Bye bye.
Thank you.
Bye-bye. Thank you.
Bye, Queen. See you later.